Alright guys, welcome back. So in today's video, we're going to be solving the question 2 and 3 from the first chapter of the Hibbeler textbook, Mechanics of Materials, 8th edition. And in the first one, we need to determine the resultant internal torque acting on the cross sections through points C and D. And we know the two supports that we have at point A and B allow free turning of the shafts, meaning we won't have any moment at point A and B. So as always, when we are trying to figure out the moment about a specific point, like in here at point C or D, we're going to do our sections. We can go either with the left part or the right part in this question. In this case, since we don't have any moment at A and B, so we can pick up either the left one or the right one. It seems that the left one is an easier choice. We can call this axis maybe X. So we are trying to find the moment about point C. So, and what we're interested is the moment about point C, and we have to figure this one out. But how we're gonna find that? So we're gonna go with the left portion of the shaft. So we will have something like this in here, and we have this moment of 250 Newton meter. Obviously, if we want to have a moment at point C, which is the point that we're looking for, it has to be in the opposite direction in order to make a clockwise moment. If we look at the x-axis from the point of view of this little guy from here. First of all, we are in the equilibrium, so sum of all moments in here has to be equal to 0, and since we are looking at the moment about point X, we can show it sum of all moments about X. So pretty easy. We basically have the moment of MC, which is a counterclockwise moment. So we're going to consider it as a positive moment, and we have a clockwise moment of, so this moment, if we look at it from the point of view of this guy, it will be a clockwise moment. So minus 250 Newton meters equal to 0. That shows the moment the point C will be 250 Newton meter. So the second part is finding the moment about point D. Again, we can take either the left side or the right side, and it seems that if we go with the right side, we only have this little bar in here. But since there is no other moments or torque to cancel that one out, we can call that one 0 2. So no moment for the point C, and we have no moment for point D, and we have 250 Newton meter moment about point C. Let's move on to the next question. So we have the same thing. We need to determine the resultant internal torque acting on the cross section through points B and C. So here we have a different story. We have moment on one side, and we can see the torque of 500 pound-foot on the other side, but we have a surface, rough surface at point A, which means we have some moment at A. So the reason I mentioned that is that we have to take into account if we are going with the left side of the bar. So we have to figure out the moment or the torque at point A here too. But it's easier to go with the right side of this shaft because it's gonna cut some steps for calculating the torque at point A. So if that's the case, we're gonna start with the point B first. So the free body diagram that we have the big part and the small part. So we have 500 here, pound-foot. We can use the same axis in here. We're gonna call it X, and we have the other guy looking at it. So we are in equilibrium, same as previous question. So sum of all moments has to be equal 0. So we have 500 in there. We have 350 pound-foot in here, and we have to figure out the moment of B. So as we can see, the other moment at B has to be in this direction in order to cancel out the 500. So we call clockwise negative, so minus 500 plus 350 plus the torque of the point B. The torque of the point B is equal to 0, and from here we can find MB has to be 150 Newton meter, and the direction is the direction that we are showing in the figure. And we have the same scenario for point C. Again, we are going with the right side. If you want to go with the left side, we have to figure out the torque at point A. So the point C is easy. You have just this little part of the shaft, and this will be 500 pound-foot, same as the other one. So the moment at C has to be in the opposite direction, basically MC minus 500 is equal to 0, and our MC will be 500 pound-foot, which would be the answer for the point C. So yeah, I hope all this made sense. Let me know if you guys have any questions. Feel free to drop it in the comment section, and check out the playlist. We are covering different textbooks in this channel. Let me know if you have any specific problem in your mind that you want me to cover it in the next videos, and I'll try my best to make that video in the next ones. And you guys take care. I'll see you in the next video. Have a good one.